Adding and subtracting vectors, introduction. Okay, we're going to learn about what happens when you add vectors. So when you add two or more vectors, terminology-wise, you're finding a single vector called the resultant vector. Okay, so let's have a real-life example here. You got a tug-of-war game. These four people are pulling to the left with forces of 100 newtons, 87 newtons, 95 newtons, and 102 newtons. So you can actually add up those vector forces and figure out that those people, if you just added those together, they're pulling to the left with a force of 384 newtons to the left. So you can just add those forces together. That's an example of adding vectors. Okay, let's say everything's not in a straight line here. Let's say you're walking somewhere. You walk 800 meters north. And then you decide to turn west 600 meters. So you go west 600 meters. It might be a terrible diagram. What is your resultant distance? So the resultant vector would be, so you walking 800 north and then 600 west would be the same thing as if you walked, it's just Pythagorean theorem that, 800 squared plus 600 squared square rooted, would be 1,000 meters. And then if we find that angle in there, using tan, opposite over adjacent, we would get 37 degrees. So we could say that your displacement, the distance that you ended up walking, is 1,000 meters north, 37 degrees west. We call that your displacement. That's an example of adding vectors. Okay, so let's get into the specifics. Vector addition. So let's say you have vector A and vector B. There's actually two methods for adding vectors. So if you want to add vector A and vector B, here's one method. Okay, first method is drawing them head to tail, or the triangle method. Fight. Sorry, disagreement. So if you look at it like this, we want to place the vectors head to tail. So we'll draw vector A like this, vector A, and then we'll place vector B so that the vectors are head to tail. There's vector B. Okay, so you can see that the vectors are placed head to tail, and it will create a triangle because the resultant vector is going to go from the start of A to the end of B. So that we call the resultant vector, or A plus B. So that's one method called head to tail method or triangle method for adding the vectors. So that's when we go head to tail and then we draw the resultant vector. And then we would be using things like sine law, cosine law to find that length. Okay, another method is called, parallelogram method, or tail to tail, I guess. So that's when you place the vectors tail to tail. So we would take vector A and vector B. I guess I'll draw that over here. Okay, so we would take vector A like that. That's vector A. And then we would take vector B. I'm drawing these probably terribly. And we replace them tail to tail. And then we would complete the parallelogram. So we draw like another vector B over here. And then another vector over there. And then, just use another color. The addition would be the diagonal. So you can see you're kind of doing the same thing as the triangle method because that's like vector A. So this would be vector A plus vector B. So similar methods. If you place them tail to tail, that's called the parallelogram method because you're kind of just redrawing A over here. So they're kind of similar methods. And that's how you do it. Okay, so let's just talk about a couple weird cases. What happens when vectors are parallel? Okay, it's not going to make a triangle, obviously. So if you had like somebody travel it, so say you were going that way and then you went the other way. Well, your resultant vector, it's going to be like, where did you end up? That's going to be, oh, maybe I should draw it the other way. Sorry, that should go the other way. That's where you started and that's where you ended. So that's going to be your resultant vector. So adding A plus B together, that's what it gives you. Or if you're going in the same direction, so let's say you have two vectors, you're going like that far, and then you're going even farther, your resultant vector is just going to be, boom, the total. That's going to be how you would add the vectors together. Okay, I'll just label them. So say that's vector A, that's vector B. This would be vector A plus B. Here, if this was vector A and this was vector B, this would be vector A plus B. So these would be like if these are parallel vectors, how you would add and subtract, or add. Okay, let's just talk quickly about subtracting vectors. Turns out we don't do that. We actually just add their opposites. So if we wanted to add, let's say vector P, we wanted to subtract vector P and vector Q, instead of subtracting them, we actually add the opposite of them. So we would actually add the vectors, but we'd add the opposite of vector Q. Right, so if like vector Q looked like this, well, the opposite of that would just be like that. So that's kind of why we needed to know, whoops, I just drew a P. It's kind of why we needed to know what opposite vectors are. So they help us when we're subtracting vectors. So we don't subtract vectors, we add their opposite vector. There's also something called a zero vector. Nothing fancy. It's just equal to 0. So like, let's say you were trying to add two vectors together and they were identical but in the opposite direction. If you added those together, you would have gone nowhere. So it would produce a 0 vector. It's written as 0 with an arrow over it, and it has no magnitude and no direction. So it's kind of weird, but anyways, that's what happens when you go nowhere. And I think we're gonna stop it there, and I'm gonna do a geometric example in the next.